Oh, what a glorious thing to be, a healthy, grown-up, busy, busy bee, whiling away the passing hour.
My name's still John, and before I start this video, I just want to say a couple of things. Firstly, I'm not a trained engineer. I've never received any formal training in machining, and that's one of the reasons why I don't show many, if any, machining shots in my videos. I don't want anybody to copy what I do, thinking that I am doing it with any degree of experience, and perhaps if you hurt yourself doing it the way I do, I don't want to be responsible. That said, I will try in my videos to follow a similar procedure each time. I'll describe what I'm trying to build, the philosophy behind the design, and then I'll take it piece by piece until we have a built-up tool at the end of it. This is the low-profile rotary table featuring a pin indexing vernier scale, which I alluded to in one of my other videos. And well, let's get on with it, and let's hope you find it interesting. This is the drawing of the base plate. There's a central hole 20mm diameter, which I've already bored for the bearing spigot, and now I'm on to the 6mm diameter equi-spaced holes on a 80mm diameter pitch circle diameter. In order to make these holes, I shall be using the PCD function of the DRO. If I now pan up to the DRO itself, which is partially obscured by the spindle. There we go. I'll just quickly demonstrate how this works. I've already set the parameters, but you merely set the PCD function, select which plane. This is the X and Y plane, so that's already selected. The center position is where the spindle is centered over the center, obviously. The diameter of the circle is 80mm. The starting angle is 0, which is along the plane of the table. The end angle, which is 315, it goes in an anti-clockwise direction 315 degrees, and that gives us 8 holes equally spaced, starting at hole number 1. If I now crank the x-axis from right to left, zeroing the DRO in the x-axis at 0, always difficult. There we are, overshot, but only by 5 microns. Not super critical, but I do like to get it exact if I can. Oh dear, oh dear. Oh, there we go. Right, there we are. Now lock the table in those positions in both directions, and we're set up to drill the first hole. When that's done, just click the left arrow and you go to hole number 2, and we move on to the next one round, and so on, all around the circle. Until we end up with the last one. Right, well I'll drill those holes off camera. They are in fact only 8mm deep, so what I'll do is first I'll spot them, the spot drill to something like 6.5, 7mm deep with a 6mm drill, possibly even a 5, and then open them up to 6mm with a end mill to give me a nice flat bottom hole. And I'll bring you back when I've finished drilling those. Well, there we are. A little while later we're back with the plate finished. The holes on the pitch circle diameter have been drilled, blind drilled to a depth of 7mm, and then I've run a 6mm end mill down just to flatten off the bottoms of the holes. I'll drill the mounting holes and the holes for the clamp plates later on, after I've finished construction of the majority of the rest of it, and I can assemble it and see how they align. That way I can just position them and spot through onto the base plate. Well, that's the end of the first little episode. The base plate is, well, I made a good start on it. The next video will be the commencement of the machining of the rotary table itself. And once again, if you have been, thanks for watching. Catch you next time.